If networking is so large and it's growing so much, where are all the network engineers? Are you familiar with the Fermi's paradox? This Fermi's paradox essentially is if the universe is so large with all these planets and stars and anything, where is everybody? We think something like that is happening in networking.
Where do you see the need to attack complexity and address those things?
If you look at the United States, you look at Bureau of Labor Statistics, after software engineers, one of the highest number of jobs in all of technology is network engineers. But something like a quarter to a third of network engineers are retiring by the end of this decade without replacement. I'm talking about just replacement rate. You can't just start in networking like you can in computer science. There's no hello world equivalent for networking.
It's a hard skill to learn.
How do we remove the parts that nobody wants to do? And what we're doing with models is fully autonomous networks.
The networks that run modern businesses have never been more complex. More devices, more data, more security pressure, and fewer people who can manage it all. The result is a widening gap between what companies need from their infrastructure and what their teams can realistically operate. Meter wants to close that gap. For nearly a decade, CEO and co-founder Anil Varanasi has been building a fully unified approach to networking. Hardware, software, delivery, and now AI all working together as one system. The company's latest leap is Meter Command, a generative interface that turns plain English into dashboards, queries, and real network actions. Welcome back to IT Visionaries. I'm your host, Chris Brandt, and today we dig into Anil's original vision, the philosophy behind bespoke AI for infrastructure, and how the role of the network engineer is about to change. Anil, welcome to the show.
Chris, thank you for having me. Really appreciate it.
I think I'm glad we get a chance to talk about networking because, you know, with everything we talk about cloud, we talk about AI, but everything at the core of it is network. And I know that, like, you know, that's both good and bad for the network engineers because it's a network problem. It's a network problem, and it's rarely ever a network problem. But yeah, I mean, it is such a core piece of the plumbing that I think people don't consider it enough when they're building a lot of these new infrastructure. You know, this new infrastructure. So I'm excited to hear about, you know, sort of the new things that you guys are announcing, the things you do. But let's just step back and kind of, I would love to find out like where your head was at when you started this company, and like what was the problem you saw out there that you're like, this I can't take this anymore. This needs to get fixed.
Yeah, I think at the end of the day, we just think networking is very important. The way that it had been done prior was not something we had liked as customers ourselves. And then we thought it could be way different, better for customers. So, you know, I think, you know, when you want to look back at these sort of things, usually there's this tendency you want to romanticize how it happened, but a lot of it was just our own problem. So we want networking to do better. You know, it's hard to figure out what ISPs are available. It's hard to figure out how to install networks, configure them, deploy them, maintain them, scale them across hundreds, thousands of locations. And it just felt like nobody really cares about networking anymore. And I care about networking. The people that work here care about networking a lot. So,
and I don't think it's ever been more important, right? I mean,
yeah,
with everything that's going on now, it's center to everything.
It's probably one of our core bets with the business is that we believe that the internet will grow and everything in the world is packets, and that will only increase.
Yeah. So I know that, you know, you kind of had these personal challenges, you know, but there's a lot to networking these days. I mean, it's not like back in the old days where it was just like connecting a T1 or, you know, a DSL line or something to a business and kind of running. I mean, now we have complex, you know, net WAN architectures. We have complex internal network architectures. And then we have, you know, things like, you know, Kubernetes and, you know, sort of stateless kind of apps and things like that. And that necessitates a sort of different approach to networking and all that as well. In addition to all the wireless stuff, and then like all the security stuff gets dumped into the networks bucket as well. And we've got BYOD. I mean, like, so how do you go about addressing such a wide range of challenges?
Yeah, it's an interesting question. It's actually core to how we thought about solving the problem. So if you think about usually how networking as an industry came about, it's one of the largest industries in all of technology.
Hmm.
At one point, Cisco was the largest company in the world,
Yeah.
but even they built their stack entirely through acquisition. Switching was bought from somewhere, wireless was bought from somewhere, security, observability, and then it just sort of smashed together with just sales and marketing sent over. But even on top of that, what companies had to do or customers had to do is then buy additional products from many different companies. Like you said, it's for WAN and wireless and security and observability and SD-WAN, VPNs and tunnels and all these different things.
Yeah.
So we took, maybe in hindsight, a very naive and sort of incurious approach is we decided to build all of it together entirely. So we have an ISP product that helps procure ISPs, then routing, switching, security, wireless, cellular, SD-WAN, VPN, IDS, IPS, DNS security, all of it built in a single platform, single hardware ecosystem, single firmware image, single operating system, single API, and single application to control all of this. And it took many years to get it off the ground. But what's sort of curious to think about is before we came along, nobody had built the entire network from the ground up.
Hmm.
Obviously, we have the benefit of standing on the shoulders of giants. There's been amazing companies that helped make networking happen the last 40, 45 years.
Yeah.
But it was all through acquisition. And if we look back and said, this is how much we're going to use internet, and this is how much networking is going to be used, but we're going to build it in this like hodgepodge way, none of us would do it that way
Right.
at all. So the entire thing is built from the ground up, from the hardware on up, fully together. And it took us years to get that right in the beginning. And in the beginning, it was just R&D. We didn't even sell the product to anyone until it was fully cohesive together, which is also a different way to start accounting.
Yeah. Yeah. Well, you just used it you kept it all for all the good stuff for yourself, I guess, right?
Until it was great.
Yeah.
We don't believe in trying to sell products that are not great. And that's the other thing, right? You're coming into an industry that has incumbents, but also many point solutions. Just the testing industry for Wi-Fi has multiple billion-dollar companies. Is how big networking is.
Yeah, it is.
Just testing for wireless. So what you want to do is build products that are cohesive, that are reliable. And in our case, we want to build beautiful products. And so it's not that we wanted to keep any of this to ourselves. We just didn't think it was good to give it to other people.
Yeah. So, I mean, I think there's a lot of anybody who's worked in networking and had to work with a multi-vendor sort of environment knows the challenges of that because, the protocols, networking protocols are ancient in many cases, and the implementations of them are not always entirely consistent either. And so interoperability has been a challenge. You've had a lot of, proprietary technologies within networking equipment that, limited, cross compatibility. So it has been kind of a hodgepodge mess. And, you have the challenges of well, do you go with sort of this thing that's integrated, or do you go with best of class, or do you, how do you assemble all this? And quite frankly, I mean, there's a lot of pieces to networking. It's hard to put the whole stack together, especially when you loop in security into that mix, right? But I think the thing is that's interesting that what you're doing is it's not just the products, but it's the delivery aspect of it too, because that ISP thing you're talking about is not an easy thing to do either as well.
Yeah.
So, I mean, like, where do you start with all this? I mean, is this kind of like more of a software defined networking kind of environment, or is this, like, or is there hardware, or is this all like a services kind of focused thing? I mean, like, how would you describe yourself?
All three of those.
Three of those. Okay.
So you can see the hardware behind me. We design, build, and manufacture our own hardware. Then the firmware is ours, operating systems, distributed systems, APIs, applications, models, and the whole thing is integrated for all the products. And then the delivery of these services matters as well. Usually, companies are rewarded by customers for having better integrated product, a easier delivery model, or a better sort of economic and incentive aligned pricing model.
Mm-hmm.
Those are the three things that when we looked at products that we like, either had one of those three, which is, it's a better integrated product, easier delivery, or more aligned pricing with the customer and the business. We said we should do all three. And it is hardware, it is software, and even on the software defined networking part, we admire Casado and Nick McCone's work a lot. We've taken that even further than what anybody's done. For example, if you see the switch behind me, down to a port on that switch is actually entirely virtualized on the backend for us. So what that means is as I'm talking to you, I can open up my phone and configure thousands and thousands of pieces of hardware that exist entirely virtually, that when the hardware is plugged in, downloads the state from our backend. We call this desired state networking because there's a desired state for every network. There should be a single source of truth, and that should come down. So it's that integrated product. Then on the delivery front, you're right. We handle everything from figuring out who the right ISPs are, making sure those get to a business, designing and configure and testing the network and delivering it. And then our pricing is that we take on the capital risk, not our customers. Usually, it's networking is big CapEx and big OpEx.
Right.
We set it up so that we're a little bit lower on the OpEx than what customers usually end up paying today. And the CapEx is zero.
Interesting.
We are not taking CapEx and amortizing into OpEx. The CapEx is just, you're happy to go into why we're able to do that and take such a bold bet for the business. But from designing and manufacturing the hardware all the way up to the services and how the business model is designed, the whole thing is meter entirely.
Yeah. Well, I think the no capex is sort of an interesting idea because I think right now in particular, what I've seen from so many companies is that there's tremendous uncertainty in the market. There's, the economy, political environment. There's, like all sorts of, new competition, things like that. So I think businesses are very uncertain about where things are going. And so what I've seen is the trend to focus on cash flow preservation more than anything now. And I think, that sort of OpEx kind of model or, like kind of fits into that. But, like there's a lot of capital tied up in network equipment. Like how do you manage to that, and how do you handle refresh cycles and all those kinds of things?
Yeah, so there's three interesting things we do on pricing. First is when customers have existing hardware from legacy providers, we'll buy that out entirely. So there's no sunk cost for them.
Okay.
Because usually for IT, it's difficult to go to procurement and finance and say, hey, the thing that I convinced you to buy 2 years ago, I want this new thing now.
Right.
So that's tough. So we want to make that easy. So if there's existing hardware, we'll buy it out so there's no sunk costs. Second, when we build When we're installing hardware, like I said, there's no CapEx. Third, when we build new hardware, because there's a new spec from IEEE or something new we invented, we will upgrade our customers automatically without any additional cost. So there's no end of life, end of support problems. Where usually what happens is companies end up pushing it further and further down the can, and they end up being on infrastructure that's a huge risk and out of compliance for them.
Right.
And on top of this too, we can take our contract, and about a third of our customers do this, I think, and it can be a capital lease on the books. So if customers have huge cash they want to spend, because that's how their budgets work and they're a business that likes spending CapEx, our contracts can be on the books as capital lease as well. But from a TCO perspective, it's massive savings, regardless of how you end up doing accounting for it. So we'll buy out what you have, we'll install the best things, and when we make even better things, we'll give you that too.
So how do you, and like that's a lot of equipment potentially that you kind of have to front into, these, how do you capitalize yourself to be able to build all that stuff?
It certainly is a lot of equipment. And we are structured in a way to be able to do that. And I'll talk about that in a second. But on top of that, it's important to recognize networking has enjoyed incredible margins the last 40 years
That's
as
true.
well. But the way we're set up,
which is great because it's a market ripe for disruption. So
that's right.
This episode of IT Visionaries is brought to you by Meter, the company building better networks. Businesses today are frustrated with outdated providers, rigid pricing, and fragmented tools. Meter changes that with a single integrated solution that covers everything: wired, wireless, and even cellular networking. They design the hardware, write the firmware, build the software, and manage it all so your team doesn't have to. That means you get fast, secure, and scalable connectivity without the complexity of juggling multiple providers. Thanks to Meter for sponsoring. Go to meter.com/ITV to book a demo now. That's meter.com/ITV.
The way we're set up is our incentives are aligned with our customers and with our partners, which is when we deliver a great network each month, each quarter, each year is when we get paid. If we don't deliver a great network, we don't get paid. But what we're trying to do is not just acquire the customer forever, but also the space forever too. So let's say we install in a manufacturing facility or a data center or an office anywhere, and that customer is happy with us. And when they grow their business from that space to the next space, they take us with them. Mm-hmm. And something like 98 or 99% of the customers take us with them, by the way. It's remarkable how little attrition we have in that. And then...
Well, and I would imagine your model is really beneficial in that sort of a scenario too, because if you have to buy redundant gear, you have to like have a big capital expense for redundant gear to like do that migration. You kind of get around that here with what you're offering.
Yes. Yeah, and then we then leave the hardware there in that space for the next tenant. So the investment we're doing is not just in the company, but also the space, because we want this to be great infrastructure. We think about it as infrastructure. I sort of think of all of life as an OSI model, but a building has electricity and water and telephone lines, and there's power meters, water meters. It's why we're called Meter too. It's not an accident.
Gotcha. Yeah, if we could just get rid of that, layer 8 problem, I think everything would run smoothly, right?
Yeah.
So I think one of the reasons why network gets blamed for so much that's really not network's fault is because people just fundamentally don't understand network, and they don't fundamentally understand the challenges of network. I mean, I remember the days of putting in big fat pipes, going overseas, and people are like, why are my files going over so slow? And then you'd have to explain to them the challenges of latency and things like that, and sort of the physics of how things can get transferred across a wire. but I do think it does seem to many to be like a sort of arcane science. What do you think are some of the biggest misconceptions about networking that you see people struggling
Yeah.
with?
So I do think it's the network's fault. I don't think it's the network engineer's fault. So those are
Okay,
two separate things.
sure,
I do think it's the network's fault a lot of times.
yeah,
But majority of the issues in networking happen because of configuration issues and compatibility issues. When you have a network, I don't know if I can share stuff on this. So if you look at this, this is the legacy rack on the left side here. This is 16, 17 different companies.
yeah,
And this is meters rack. It's one rack. So when you're trying to build and design a network, you're dealing with this where you're trying to get these things to work together, where one part of the stack implements BGP a certain way, this feature is implemented a certain way, this firmware doesn't work with this version of the firmware. And then it's this cascading domino effect of how this whole thing is not compatible. And network engineers have to go try to configure this in 10 different platforms, many different APIs and CLIs and all these things. And that causes a lot of issues. Imagine if your car was made each part without knowing how it was going to fit together in the end. Would you get into that car?
yeah. No, no,
That's what networking is today.
yeah.
So I do think it's a network's fault, but it's not the network engineer's fault.
Yeah, no, it is complicated, and like as you say, I mean, like it. I remember the days when I'm not going to mention who it is, but when you'd have like a core router and you had two operating systems on it, and depending on what tasks you were trying to
Yeah.
work with, you'd have to use a different CLI for each
Yeah.
piece. Yeah,
I remember those
within
Cisco
the same
days.
device, which is crazy.
I'll say it. I remember those Cisco days. I'll say it.
Yes, that would like CatOS and iOS, like that mix was
Yeah.
something interesting challenge. But I mean, I think the other thing then you saw was that especially from the CLI side, you saw a lot of people like replicating some of the basic functionality and commands so that it would, even though they were different manufacturers, they still kind of used largely the same command
Yes.
sets.
Yes. There were a bunch of lawsuits about this too.
Yeah,
High profile
which it
ones.
should be probably,
Yeah.
right? But I mean, like from a network guy's perspective, that was really nice because that
Yes.
you could like I can it's an easy transition, right? But I mean, like how do you guys operate? I mean, do you find that most of your customers want a CLI or they want a GUI or because back in the day, like GUIs were frowned upon, like the real network engineers always use the CLI, right? I mean, what does that landscape look like these days?
Yeah, we find our customers that are network engineers, they just want a great network,
Yeah,
honestly. That's ultimately you just want a network that's fast, that's reliable, and that's secure. Because that's what their colleagues and their customers are expecting from them.
for sure.
The reason dashboards and GUI was frowned upon is they're sort of rigid, right?
Well, and
Somebody,
half the time they didn't work too.
yes, somebody inside one of these vendors and these legacy vendors, there's a project manager, there's a designer, there's an engineer, and they sort of decide what things are going to be. And it's sort of like Moses coming down from the mountain with the tablet that this is how it shall be from now on. Um, and we have a great software product too that can show every inch of it. And one of the core tenets that we have is that just because we're doing this model of hardware, software, services together doesn't mean we should take away any control from the network engineer.
Mm-hmm.
We hope to keep adding and adding and adding and adding things so that there's granular control over everything on a network. But at the same time, we do want to invent new things and new ways of doing things.
Right.
So about a year and a half ago, we released this product called Command. And Command is a product where models were trained by us on how we build software, how we configure networks, and how we design software and what our hardware can do. So these are models that know this and networking really well.
Mm-hmm.
And we released Command and people have really loved it. And there's sort of three main things Command can do. And it's a bit of a tongue-in-cheek name because we called it Command. It's like command line.
Yeah.
But it's entirely natural language based, where you don't have to remember some esoteric commands to try to get what you want.
Right.
So the first thing Command can do is you can type in natural language and it will answer whatever you want across thousands of sites and thousands of pieces of hardware, whatever it is, it can answer those questions. Second thing it can do is take action. You can say something like this to Command and we can send you some B-roll to show is create a new SSID, call it Future TV, put it on this VLAN, make sure the password auto rotates every 23 hours and 2 minutes, and make sure it's on all APs. You can literally type that out and it just does it. So second thing you can do is take action.
That's pretty cool.
The third thing is addresses this GUI thing we've been discussing, is because our models are trained on how we write software and how we design software and what our capabilities are, it can actually write software on the fly. So if you say something like, hey, for Chris's laptop that's connected to our network, make me, a TX chart, an RX chart, and show me all the connection events. It'll just, at the speed of a Google search, write that software for you that looks exactly the same as our dashboard. And now it's available for you to have your own custom software.
That's interesting because, one of the biggest challenges I think for the networking team is having consistent and updated documents and information available. And I think, I always remember like the low man on the totem pole when they came into a company, the first thing that they often got tasked with was go map the network for us and update the documentation, which was the worst job you could have, right? Because it was just, it was miserable. It was miserable. And it sounds like you've kind of got a way to like interrogate the system to get information out of it, which is an interesting approach to it.
Yeah, because we believe network engineers should have immense amount of control over their infrastructure. And how do we reduce the gap of being able to do so?
Mm-hmm.
Yes, we'll make really beautiful, great software that we believe how it should be, but we also recognize everybody's use case might be different. Mm-hmm. And how everybody does things might be different. So both of those we want to be able to do.
Yeah.
And they intersperse very well together because our models are trained on the former to be able to deliver the latter.
Yeah.
So it just keeps going together.
Well, it's interesting because I always found that like if you came across something that didn't seem to make any sense, that's the last thing you should touch because somebody probably did that for a reason and nobody's been able to get it to work, right? But it seems crazy. It's like, why would anybody do this? And it's like, but it's hard to figure out why that may be.
Yeah. That's why having this unified architecture and a single platform is so beneficial. Every part of it is meant to talk to the other, and we know how it's built. So,
tell me a little bit more about, how AI is integrated into what you're doing. I mean, obviously Command, is that chat-based interface, natural language interface to get at things. But I mean, like, you're not going to get rogue AI running away and and making all kinds of changes on the fly on you, I assume. But I mean, like, where does it all fit in? Is that part of your security stack too? Is it like how do you have it all integrated?
Yes. So first, I think like words are really important.
Yeah.
So we try not to say AI at all.
Okay.
Um, because it's like one of those things where almost everybody wants to call everything AI and sort of it's lost all meaning, I think. So what we think about is this is another tool in computer science to be able to build products that can be useful for customers and partners. And what we're not trying to do is say AI 20 times in our opening landing page.
But your
And
valuation will go up if you do that.
sure, sure. But it sort of doesn't make any sense as a
Yeah.
customer is like, what does this have to do with AI?
Yeah.
At the same time, we take this very seriously. When I was in university, a bunch of my research was in autonomous networks, not a concept I invented in any way. But we believe in actually also doing the opposite end of the spectrum is building models ourselves. And what's ironic about all these companies that say AI every 5 minutes is they are just using somebody else's models and throwing things over the wall without actually understanding them. We're investing massive amounts of time and capital to be able to build our own models too. So we have it seep through across our platform. Today, our models understand our systems, can give information, and take action when asked. We want to earn the trust, gather the data, and build even better models ourselves to be able to do more and more. And maybe, the National Highway Safety Administration set up a good framework for this for autonomous vehicles, where there's level 1, level 2, level 3, level 4,
Right.
level 5. With command, we're sort of at somewhere between like level 2 and 3, maybe closer to 3 than it is to 2. But if you look at the companies that were successful in autonomous vehicles, it's basically in the United States, basically it's Waymo and it's Tesla, and there's others now coming. The reason they've been able to do is they, one, control the entire stack themselves. Two, they have massive amounts of data they can work with because that's how you teach and train models. And three, you need lots of compute to be able to do something with that data when you want to train models and serve models. We have this entire stack you and I just talked about 10 minutes ago, where it's fully integrated. It's why Tesla can do what Tesla does, but Ford can't do it, because Ford buys, in the admission from the CEO itself, like parts from 2,000 other companies.
At least.
It's really hard to control a stack you didn't build. And it's the same problem in networking too for legacy vendors. We, one, have the entire stack connected. Second, we talked about that desired state networking, where everything down to a single port is virtualized in the backend for us. That is correlated with all the data everything produces. And third, you need compute. We have a long-term partnership with Microsoft that we announced earlier this year. And at our conference, we had Satya Nadella, CEO of Microsoft, speak to a couple of weeks ago, because we believe networking is really important. And for us, it has to do with models on how we can make networks fast, make them secure, make them reliable using models. But ultimately, our customers are network engineers, at our partners, at our customers. How do we provide better products for them? But you won't ever see us just do the surface level things. It's similar to how we build the entire stack. We think of models the same way. We build the entire thing and make it to be great.
So, I mean, obviously, like, what we talked about at the very beginning about sort of this huge growth in the complexity of networks and just things that the networks are being asked to do. Obviously, having that integrated single stack solves for a lot of that complexity. But I mean, like, where else do you see like the need to attack complexity and address those things?
I think actually across the entire stack. So if you look at in the United States, and again, I'm very myopic when I speak about some of these things, but if you look at the United States
Mhm.
and you look at Bureau of Labor Statistics, after software engineers, one of the highest number of jobs in all of technology is network engineers.
Mm.
But something like a quarter to a third of network engineers are retiring by the end of this decade without replacement.
Yeah.
And I'm not talking about all the growth you and I were just speaking on of how much this is growing. I'm talking about just replacement rate.
Yeah. It's not glamorous being the network engineer. I don't know that people are
For sure.
are going into it. And the thing is like, it's a hard skill to learn.
Yes.
It's one of those things that, experience is the best teacher. And I think that holds so true with networking.
So we want to do a lot to change that. It's not cool to be in networking. We want to do a lot to change that.
Well, you got those
decade.
nice looking boxes behind you. That helps.
For sure. That's step one. But the other thing is there's no hello world equivalent for networking.
Right.
You can't just start in networking like you can in computer science, and there's the feedback loops are tight. But if you look at what's happening, are you familiar with the Fermi's paradox by any chance?
Mm-hmm.
Yeah. And this Fermi's paradox essentially is if the universe is so large with all these planets and stars and anything, where is everybody?
Right.
We think something like that is happening in networking, which is if networking is so large and it's growing so much, where are all the network engineers? And what we're doing with models, and we announced this at our conference that by 2027, we'll have fully autonomous networks, is how do we remove the parts that nobody wants to do, but how do we use people's brains for really intelligent, complex things to make networking better from protocols to architectures, topologies? But it's not about sitting there and like spending 2 hours reading a log file trying to find something.
Yeah. I mean, fully autonomous networking is a bold statement.
Yes.
To say that. I mean, like, what does fully autonomous networking even look like?
So if you look at what network engineers do today, there's sort of three things, right? Designing networks, configuring networks, and maintaining networks.
Mm-hmm.
All three of those are repeatable tasks that have a deterministic outcome.
Mm-hmm.
That's what autonomous networking should do. Should be able to design a network, configure a network, and maintain a network.
So your network would understand its own topology, design its own, networking, and then maintain it and do all the, I mean, like you talk about network engineers, port adds, like things like that, moves adds and things like that, change adds, deletes. So it would handle all that stuff on its own.
Yes.
And is this like based on is this part of command? Is that like where the direction command?
Yeah, these are models that we're building ourselves. Yeah, that's right.
Okay.
These are models that we're training ourselves from the ground up.
Yeah, because it's interesting because there are best practices to how to do things. And I think that's where a lot of people get lost because, sometimes, well, I'm just going to reinvent this thing because I don't know what the best practice is because it's not even really clear all the time. It's not even clear what the optimal version of software you should be running on anything.
That's right.
And it's hard to get that answer, So it's like, that would, I mean, you're talking about a huge leap here from where we are today to, fully autonomous networking.
Yes. Yes, that's right. So, and we think it's really important. If you continue to believe that the internet will grow at the pace that it is today, and the number of people coming in that are just replacing, the replacement rate is going down, something's got to give. Mm-hmm. And we think it's a very safe bet that the internet will grow.
Yeah. Oh, yeah.
Massively. At a faster clip than it is even today.
So would you, I mean, like, where do you envision it going? I mean, because we've talked for years about, like, oh, everybody's going to go to the cloud. And then, like, not everybody said they were going to the cloud. And most people didn't go to the cloud. Now a lot of it's coming back. It's hybrid. It's all over the place. But I think the one thing that like did emerge from the cloud, that I think has got really stuck for everybody is sort of the whole Kubernetes and sort of microservices and things like that. And I think that one of the networking on that stuff is always really challenging, because you create like one just massive network space that like it kind of spins things up and kills it off as it needs it, or do have more deterministic kind of things going on in there, or and then you're fighting that battle about one of the big proactive things that you can do for security is segmentation, right? So that's kind of the opposite of segmentation. It's sort of just like throw it all in a bucket and let it have at it, right?
Sure.
So like where do you see that all going with this?
Yeah, I don't think I have all the answers. It's
Yeah.
sort of like trying to predict what will happen on a Tuesday and what we'll all have for lunch. I think you can sort of guess, but you're not ever going to get it right. Um, but whether it's on a Kubernetes cluster, and I haven't deployed a Kubernetes cluster myself in a couple of years, so maybe things have changed. So my mental model might be wrong about this. To a data center, to a manufacturing facility, an office, a warehouse, a retail space. I think one of the reasons I've been attracted to networking is the fact that it works is a miracle.
Yes, especially if you've seen the back end of
Yes.
that. Yeah.
Yeah. And from your computer all the way to mine right now, we're in two different places of the world. Everything from how packet comes in through your NIC, then goes up the stack, TCP IP, handshakes, DNS, all the way routing to me and routing it back. The fact that it works is kind of cool.
Yeah.
And it's all open protocols. And nobody gets to do anything custom in networking. They want to talk to the rest of the internet. You have to adhere to the protocols. So no matter which type of network it is and where it is, we have solace in the fact that it's just networking at the end of the day. It's the same stack, same protocols, same RFCs. Granted, everybody implements an RFC differently.
True.
But the fundamentals are the same, because the beauty of networking is it has to be talking to something else to be useful.
Yeah. It has to survive a nuclear attack, right? I mean, that's the whole point of it.
That's right. That's right.
So like what sort of market are you going after? I mean, like who is like sort of what does your customer base look like? Are you, I mean, because you do a lot of stuff here, so you appeal to, I imagine, a wide range of companies. Where's sort of the sweet spot for you guys?
So first, for all of our customers, we do the entire stack. Mm-hmm. We don't sell just APs or just switches for anyone. It's the entire stack, which is also very unique as a networking company.
For sure.
Nobody else has that. Everybody else sells pieces, parts of it. And then from a customer base perspective, we have many different types of customers and some of the largest customers and partners that work with us. So Bridgewater, who's the largest hedge fund, is Meter's customer. Retailer that has thousands of locations, they're Meter customers. Some of the largest independent schools where wireless is incredibly challenging to do when you have 30 kids on a laptop each in a small room.
Especially with BYOD too.
Exactly. We have some of the largest independent schools in the entire country running on it. We have public companies with massive security and compliance requirements running on Meter. So in each vertical, and then same thing, actually, I should mention also in warehouses and manufacturing as well, where 24/7 operations is not a nice to have. It is the only way they function.
Well, yeah, and OT can be a hot mess too.
It's so all of those, we have individual customers that have hundreds of millions of square feet with us. So it's customer base everywhere and some of the largest companies in each vertical. But maybe to answer your question on who are we going after, is we're going after companies where networking matters and companies where IT teams are asked to do more than the resources they have.
Which is
It
all of
just so
them. So
happens that's every
that's a big
company's.
TAM. IT Visionaries is powered today by Meter because every great business relies on great networks. If you're a network engineer, you know how critical uptime, control, and visibility are. Too often, you're stuck troubleshooting issues across fragmented systems or locked into legacy solutions that don't scale. Meter reimagines networking from the ground up. Their full stack solution, from ISP procurement to security, routing, wireless, and beyond, gives you deep control and the performance you need. No more piecing together providers or worrying about bottlenecks. Just seamless, scalable connectivity built for today and tomorrow. Big thanks to Meter for sponsoring. Visit meter.com/ITV to book your demo now. That's METER.com/ITV. It's a crazy market out there. It's challenging. How I mean, like you talked about like wireless networks, like factory floor has all sorts of weird technology integrations that like, have to come through. Are you doing like 5G stuff in that as well, I assume? And then like, so do you go from all that all the way down to like SAN switching and things like that too? Or like you have the whole stack?
Whole stack.
Wow. That's wild. That's wild. I mean, that's not an insignificant amount of effort to put into to build all that. I mean, that
It's a very significant amount.
I mean, there's a lot of pieces and
Yes.
a lot of technologies, a lot of protocols.
Yes.
And like, and a
it's
lot
about
of
10
like
to 12 different companies in one company.
Yeah, it really is. And then you talk about interoperability, and we also use to say, it's fully bug compatible, with with the other stuff, because sometimes you have to like integrate bugs that have been in production for so long.
That's right. You have to adhere to them.
To adhere to the interoperability. That's a lot. So what? Like where do you see where do you see the networking going now? I mean, with the rise of AI and some of these modern technologies and it's like all the stuff that's happening around the edge, robotics is making a huge uptick. I mean, there's just so much stuff going, like wireless. I mean, we talked about like 5G hasn't even approached the level of usefulness I think that ultimately is going to, the level of use that it's ultimately going to get. So that's just probably a huge and growing market as well. Where do you see all this going, and how? I mean, like obviously, fully autonomous networking is a big piece of that. But I mean, like where do you see like the next big networking challenges?
Yeah, so I can give you our view on how we've tackled it.
Yeah.
If you look at all the legacy networking companies, they are trying to build hardware for as cheaply as possible and sell it to you for as much as possible, because that gap is their margin.
Right.
That's the entire business. And then every year they want to sell you new boxes with ever so imperceptible changes. And with these model numbers that sound like hieroglyphics, where you actually don't know what they're even saying to you, to confuse you or whatever the reason is, to get you to buy boxes. So from our view, first is what we think should change in networking, and what we've done ourselves is we don't think hardware should be commoditized. We think hardware should be beautiful and great. And as part of this, we released 9 new platforms of hardware just 2 weeks ago. 3 new firewalls, 3 new switches, 2 Wi-Fi access points, and 1 cellular gateway at the same time for the entire stack.
Yeah. That's a lot.
Again, yes. And we believe hardware should be beautiful and it should be cared for. And hardware should be built on the best version of it that's possible, not the best margin that's going to yield. Because better hardware leads to better software, which leads to the better network. So first is that.
Do you build around like a common platform for all of those things, or are you kind of is each one sort of a bespoke instance?
No, we do try to keep a lot of the common platforms on how we do the buses, to how we do power, how do we do PCB, how do we do where the SFP ports to go to where the RJ45s are. There's a common design language. There's a common platform, there's a common pattern to build upon. It's sort of like Lego blocks. What can you build with?
Right.
That's one of our big advantages to be able to do that together.
Yeah, I mean that's one of the advantages of sort of having a fully integrated stack is that
That's
like
right.
I imagine that leads to a lot of, you know, good economics in terms of how you build things. And then, you know, and I think one of the other things that was really opened up the world of networking for companies like yourself, I think, was the crisis that hit sort of during the pandemic, where you were seeing people like they had to upgrade their network and they were looking at 365-day lead times or more on some of
Sure.
these things too. And so like, you know, that's got to help with sort of managing your supply chain a bit. And I think, you know, being fully integrated, you know, self-contained kind of stack, that's got to help with sort of the ability to manage that
Yeah,
inventory too, huh?
definitely. Definitely. So yeah, we think hardware should not be commoditized. Hardware should be beautiful. That's got to change. Second, I know this will sound sort of prosaic, but we actually think there's a lot of basics that can be done right in networking.
Mm-hmm.
Our industry has become alphabet buzzword acronym soup type thing where even I don't think I certainly have a bunch of things in networking I don't understand. And I've been doing networking for 20 years and
Yep.
people say some acronyms to me and I'm like, what are you even talking about? I don't know.
Well, and they reuse them too, which kills me.
Yes, for sure. So I think from how the RFCs are implemented to how protocols are implemented, the basics have to be done right.
Right.
We think if you do really beautiful hardware and the basics in networking right, there's actually a lot of room to change things. But a couple more interesting things from us. We've talked about autonomous networks.
Yeah.
One, happy to go into it more if you want. But the other part that we didn't touch upon is because of how we built our stack with the desire state networking that I mentioned, we have the same platform from 1 gigabit to 1 terabit.
Hmm.
That's also never been done. So what you'll see from us is more and more with the same platform, 400 gig, 800 gig, 1.6 terabytes. And again, this will change networking deeply when it's one stack everywhere.
Yeah. I mean, it's interesting. I think that, you know, as much as we talk about all these other technologies, there's not a single one of them that really gets implemented without the network under it.
That's right.
And I think that's, you know, one of the reasons I think that network folks tend to be very conservative in their approach to things because it's about keeping the lights on all the time. It's not, you know, like you may have maintenance windows where like, you know, you're off of business hours for applications and servers can be rebooted and things like that, but the network never gets a moment off, right?
That's right.
And so that's, you know, and I think that's one of the challenges too, is sort of like, you know, how do you continue to grow, upgrade, and service the network without any kind of interruption as well? You know, can you talk to, you know, some of your capabilities around that sort of stuff?
You mean on how to upgrade the networks and how to
But
think
just,
about
you
it?
know, sort of the sort of steady state, you know, like the redundancy of everything, the
Sure.
ability to maintain and operate it without interruption.
Yeah, I think again, having the integrated stack removes a lot of those compatibility issues.
Mm-hmm.
And having the software stack that I mentioned on how things are virtualized and there's a desired state, that removes most of the configuration issues. And what I've noticed is if you can solve those two, you've actually solved majority of the networking problems. And then we overlay on top our models, overlay on top us doing not just the hardware and software, but also doing the delivery and the integration, where we're doing the services to deliver it. And then we're helping maintain the life cycle. It's a very robust, tight network. Again, it's the network each of us would build if we had time and capital.
Yeah, yeah. Well, so I mean, on the like the services side of it, I mean, because you're delivering this as kind of a service, really. And what like how much of it do you maintain? I mean, you said that like you're giving the network engineers, you know, the control to do everything. Is this sort of like a shared kind of maintenance ownership model that you have? How does that work?
Yeah, so we do give full visibility and full control to customers. For example, if they want to go to a particular switch in a particular port and change how STP priority works, they can go ahead and change it. On what that shared model looks like, it depends on the customer and the partner we're working with.
Right.
So we might be brought into a deal through one of our channel partners where the channel partner might be doing access control for them or storage or data management somewhere for them and networking as well. And they might be managing the network on the behalf of the customer and we might be taking a backseat. So that model works. Some partners might be more resellers without the services aspect, and they want us to manage all of it, and so does the customer. That model works too. Some model is that the customer wants to do all of it, and none of it for the partner, none of it for us. That model works too. We're dogmatic on the fact that we want the network to be great. We're not dogmatic on taking away control in any way.
Yeah. Yeah. Well, and we talked about visibility too, which is a huge piece of it. And actually a
Yes.
really difficult piece of it, because in some cases visibility takes, a lot of resources and bandwidth and just from a talent perspective, like having, like you talk about like lack of network engineers, but I mean, like if you don't have people who understand, like deep packet inspection, for example, it's going to be really tricky for people to really interpret a lot of the data they get. What are you doing on the visibility side of things?
Yeah, our software, this is where we try to build beautiful software where you should be able to try to go understand things. We'll try to simplify on how to synthesize that information for our customers. So both that synthesis should be available and then the raw data should be available as well
Right.
to be able to go see everything that's happening. Um, I think we want to do a lot more on that. Models come in there too, which is, if you take infinite amounts of data that's happening in a network and models can help understand what's going on to provide better visibility, we want that too.
Yeah.
So there's a ton more we will do. But even now, every single day, we just care about, is this the most beautiful software available? Because somehow nobody else is thinking about the fact that networking should have the best hardware, best software, best people. It seems like all the other parts of technology are doing that. But we've sort of agreed that networking products will be ugly.
It's a commodity. Nobody, yeah. Stick it in a dusty
Networking,
closet.
networking is not a commodity.
Yeah. Yeah. I mean, it's funny. It's like, like people do like kind of treat it like, the forgotten stepson or something, but it's like when the network goes out, everybody knows it.
Everything in the world is packets, including this call we're doing right now.
That's for sure. For sure. Lots of packets. So what would you say to somebody who's maybe got a greenfield operation now and they're like, I got to build a data center, I got to build an office out, I got to, get my company up and running. Like what would be the way to approach that for them?
I would look at what they're trying to accomplish for their business at the end of the day. If the business is giving them the responsibility of doing that, then it's their responsibility to think about the business too. Mm-hmm. Then think about the resources that they have from a personnel and a capital perspective. Then evaluate products for what they are. Is this the best product to buy? Yes, sort of economics matter and all those things matter, but it has to start with, is this the best product? And if you have an understanding of what the business wants and you're thinking about the resources and then you're applying that to the best product, I think that's how you build great networks at any scale.
Yeah. Yeah. Well, so if people wanted to, like talk to you, see you, get a taste of this meter stack that you guys have built, are you, are you guys going to be at any shows coming up? Are like, and where should they go find you and how should they contact you guys?
Yes, we're going to be at all the shows. I don't know them off the top of my head.
But all of them.
All of them. We're easy to find. We're at meter.com, meter meter.com. My email is also very easy. It's anil@meter.com. I try to
Okay.
answer every email that I get. So if folks want to reach out, that's fine too. And we have demos on the website. You can see our hardware, see our software. You can see how our customers talk about it and actually get a sense of what we do. But we're pretty easy to find.
Yeah, no, I think that's great. I think, it's one of those things that networking is for very many years been ripe for disruption. And I think, we're starting to see that happen now, which is really cool. And it's not coming a moment, too soon, because there's so much changing, and the kinds of products and the flexibility to build these, complicated networks with as you point out, limited staff that's getting increasingly smaller.
Yes.
I think that's these are key things in the world right now. So very cool to, like, talk to you about what you're building. I'm an old network engineer in my, my in my world, I'm partial to, cool networking stuff. So thanks so much for being on and sharing everything you're doing, and sharing your wisdom, and keep up the good work. Thanks so much for being on.
Thank you for having me, Chris. Really enjoyed it.